Okay, I have, so 82B, looks like this. So you're given $5,000 at 8.5%, compounded semi-annually. How long before it reaches 7,000? So the first thing is, this is a periodic growth function. And it's periodic because instead of growing continuously, it repeats or it grows over, a certain period of time. In this case, this is an R. We put our R here. We put our N here, and our N is what's the number of times compounded a year. So if this were 12 times, if this were monthly, then the N would be 12. If this were daily, the N would be 365. If it were weekly, it would be 52, so on and so forth. And in semi-annually, it's twice a year. So our N is going to be twice a year. So this function right here is a periodic growth function. P of t is our object over time. It can be any variable, P of t, S of t, R of t, whatever. But P is a consistent thing. P base 0. You don't always see this 0 here, but that means initial amount. That means your starting amount. The 1 is my consistent value. My R is my interest rate in decimal. My N is my number of times compounded. Again, it's going to repeat here. And my time is, or my T is my time. In this case, it's going to be yearly. Okay? Now, just as a comparison, what we use in this next time, continuous growth is something that grows continuously. The population, the human population grows continuously because people are always having babies. Again, the P base 0, sometimes we'll just see a P. The ERT, this is a consistent thing. PERT, again, you don't always see the P. Sometimes you'll see an R of T or Q of T or anything. Doesn't make any difference. E being the number E, R being interest rate again, and T being time. Okay, but we'll get that the next one next time. So periodic growth becomes continuous growth. The bigger N gets. So as N gets bigger and bigger and bigger and bigger, this whole function right here becomes this function. All right. So that being said, the question is how long before this thing reaches 7,000? So we put the 7,000 on the left-hand side. So this is for the P of t. All right, there's our 7,000. That's our question mark. Our starting value is 5,000. So we're going to put that right here. All right. Our parentheses, 1 plus, our interest rate is 8.5%. Therefore, our decimal is 0.085. And our N, as I said, is 2. And this is 2 times T. Okay. So then we just have to figure out our problem. Now, the process of doing this particular type of problem is funky because there's so much need for parentheses. Except if we want to, we can go inside out. In other words, I can do this first. I'm going to give this little A. Then I can do this second, add it to here second, B. And then I can raise it to the power C. And then I can multiply it by this, D. So I could do that in that order if I want. A, B, C, D. In my calculator, so I don't have to worry about parentheses, but in this case it doesn't necessarily apply. Okay, so what we're doing here is we are solving for T. We are solving for T. Remember, this continuous growth thing is for the next problem. I just did it. So if we're solving for T, we're undoing everything that's been done to it. The first thing we have to do is divide by 5,000. So this becomes 7,000 over 5,000 equals this whole thing. 1 plus 0.085 over 2, all times 2, raised to the power of 2t. All right. This, I want to simplify this as much as possible because I don't want to deal with juggling these numbers. So this simply becomes 1.4. I can do that on my calculator, or I can reduce to 7/2 and find out that's 1.4. But whatever, it's just easier to deal with. This, again, I want to do that as simplified as I can. So when I do 0.085 divided by 2, I get 0.0425, all raised to the 2t. Now I can do this in two ways. I could put it in my calculator, and what I would do if I'm going to put it in my calculator is I'd go to my y equals, and I'd go 1.0425 raised to the power of 2x. All right? And I would do 1.4. Now we're talking about something growing from 5,000 to 7,000, so it's not crazy to think it's going to be doing it pretty quickly. We're talking about it starts at 5,000, so we're going to do this. We're going to have our window be 0 to, let's say, 15, and my y max minimum is going to be 0, and my y max is going to be 10, if that helps. Okay, so there's, remember we have 1.4, and we're looking for time here. So this is our original function, our growth function. Can't see it with that light reflecting in there. Okay, and this is where they intersect. So what that means is at that point right there, this curve function, which is this 1.425 to the 2t, equals 1.4. So I'm going to do second calc intersect. And when I do this, they ask for the first curve. Well, there's only two curves. So I just push enter, enter. And then it says guess. They only intersect at one point, so I don't even have to guess. I just have to push enter. So I'm doing enter, enter, enter. And what I find is, sorry, I'm trying to get the clear for it. So at t equals 4.04 years, this interest, this will grow to $7,000. All right, which makes sense. All right, we're talking about $5,000 at 8.5% is going to go to 7,000 in about 4 years. Now that's how we did it on a graph. If we did this algebraically, I'd have 1.4, and this is more the log process. 2t. I'm going to take the log of both sides. Now I can take log base anything, but I'm personally just use log base 10. So I'm going to take the log of both sides. And what happens over here, I'm going to write it out like this. What happens over here is my exponent drops. So my exponent, when I take the log of both sides, pops right in front of here. So I have 2t. So I have a number, log of 1.4 equal to 2t times another number, log of 1.0425. And now I need to solve for t. Well, I solve for t by dividing both sides by 2 log of such and such. So t equals log of 1.4 divided by 2 log of 1.0425. This should come out to the same value. So we do log, where am I? Log of 1.4 divided by, and I want to make sure I include everything, so I do 2 in parentheses log 1.0425 close equals 4.04. So that is the same answer as we should expect. So let me go over this again. It's a little bit scattered here. First things, most importantly, when it says semi-annual, you're talking about a periodic growth function. All right, so monthly, yearly, whatever. That semi-annually directs us to using a particular n. In this case, the n is 2, so we use it there and there. Our time is our t, our r is our interest rate in decimal form, our p base 0, or just p is my initial value, and p of t is my ending value. 7,000 equals this whole thing. I isolate the t, which means I'm dividing by 5,000, simplifying as much as possible, blah, 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 blah. I eventually get to a point where I have an isolated base to a power. At this point, I either use logs to solve for the exponent, which means I take the log, both sides, and the exponent drops, or I could do it in my calculator here, and I see that in 4.04 years, it's going to grow to 7,000. Okay? Okay. That was probably a little long-winded. Maybe I'll make this a little shorter. Okay. So, We have 10,000, this is number 84. We have 10,000 bacteria in 1 hour, it grows to 25,000. What is the doubling period? In other words, how long does it take to double? And what is the number of bacteria after 3 hours? Well, what we're talking about here is, we're talking about continuous growth. Bacteria, like the population, the human population, grows continuously. Therefore, we're dealing with this function, P base 0 ERT. Again, sometimes you see the 0, sometimes you don't. All right? My initial value is 10,000. My E is my number E. My R is my unknown at this point. Actually, there's 2 unknowns. I'll take it back. There's not 2 unknowns. T equals 1. All right? And then this equals 25,000. I solve this the same way I always do. I'm going to isolate my E. So I'm going to divide both sides by 10,000. This comes out to 2.5 equals E to the R. Remember, we multiplied that by 1 for 1 hour. Okay? Now we take the ln of both sides. And I end up with my growth rate is ln of 2.5. So the ln of both sides gives me ln of 2.5 equals R. That's my R. That's what I will use now. When I go back into this function, I'm going to do this. I'm going to say 20,000 equals 10,000. This is overkill here, but I'll just show you how to do it. And we'll go to the more simplified version. To the ln of 2.5 times t. So what this is telling me is how long will this double? From 10,000 to 20,000. Or from 2 to 4, or from 1 to 2. Whenever I divide this by 10,000 on both sides, I get this. This is not a coincidence. This is going to happen every single time. So at this point, now I take the ln of both sides, and I get this. And I find out that t is equal to ln of 2 divided by ln of 2.5. I'll let you put that in your calculator. That comes out to, I don't know what it was, 0.75 I think it is. I think it comes out to 0.75 about. And what that means is 45 minutes. Okay? Now our growth rate is going to remain the same. Our time it takes to double is 0.75 or 45 minutes. So from there the question becomes, how many bacteria after 3 hours? So I already calculated a doubling period, but that doesn't apply here. I simply take this number, where is it? This number right here is ln of 2.5, and instead of having t equal 2, I put that in for 3. So I take my 10,000, and I do my E to 2.5 times 3, and my question is, what's that going to equal? Now remember, this doubles every 45 minutes, and we're talking 3 hours. So what we're really talking about is this doubling 4 times, from 10,000 to 20,000, 20,000 to 40,000, 40,000 to 80,000, and 80,000 to 160,000. Now it's not exact. This is about 45 minutes. This is about 0.75. So it goes to a few different decimal places, which means this number, when used exactly, is going to give me slightly the same, but this is going to double about 4 times. And if I put this in my calculator, 10,000 times E raised to the, that's an ln of 2.5, thank you very much, ln of 2.5, close parenthesis, times 3. Making sure it's all in my exponent, gives us 156,000. I screwed up a 0 there. In fact, that sort of brings me to another point that I can let you do. Blah, blah, blah. Where's the ln? 2.5, close, times 3. Boom. So there's our 156,000, which is about what we're looking at. My point here being this actually works out, that it grows by a factor. So even if I wanted to take this, and instead of having 10,000, I have about 30 seconds left, instead of about 10,000, I'm just going to do 10. I would work this out, and instead of getting 156,000, I'd get 156. And then the same way I would change this from 10 to 10,000 is I change this from 156 to 156,000. So I can do that in that fashion as well. All right, this is a little scattered, a little rushed. I hope it makes sense.